Let's build electron configuration of following three elements, zinc, bromine, and cesium, and talk about their location on periodic table. Before I can do off-bar, I'm going to do the order. So I write 1s, second row I put 2s, 2p. The third row I do 3s, 3p, 3d. Then I continue with 4s, 4p, 4d, 4f, and 5s, 5p. I'm not writing the rest. I think I have enough. 6s, and I stop. Then diagonally we are going to follow this, and that's how we are going to fill the sublevels. So this is sort of a trick that all chemistry teachers agreed will work. So I want you to practice until you perfect this game. So let's just do. Zinc only has 30 electrons, so I put 2 of the 30 in the 1s, then 2s2, 2p6, then after that is 3s, then comes 3p6, then 4s2, 3d10. And we have our 30 electrons, and I followed my off-bar. In terms of a noble gas, this is your noble gas argon up to here. So this could be expressed as argon in bracket 4s2, 3d10. Also, the other piece of information is your valence electrons are on fourth shell, and it's a s block because it's in the s second group, and we are going to talk about it on the periodic table. So you should find this in fourth shell, group number 2. Now let's look at bromine. Bromine has 35 electrons, so we continue with the diagonal rule, and we go 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10. We have covered zinc. We need 5 more, which we put it in 4p5. Now the fourth shell is your valence electrons. In terms of a noble gas, it's argon, 4s2, 3d10, 4p5. The 4p and 4s are your valence electron. It says you're sitting in group number 7, halogens, which is true. Now cesium is the biggest one that you need to know in IB, so let's just fill it up. 1s2, 2s2, 2p6, 3s2, 3p6, then comes 4s, 2 electrons in it, then comes 3d, 10 electrons in it, 4p, 6 electrons, 5s, 2 electrons. After 5s, I'm on 4d, 10 electrons, then 5p, 6 electrons maximum, then 6s, and you only have 1 electron left. Put it there. And that's good because you are in the 6th shell and you are in group number 1, you are in S block. In terms of a noble gas, you could be expressed in terms of xenon, which is 54 electrons. So this could be expressed in terms of xenon, 6s1. So this is your valence shell or valence electrons. Now if you look at a periodic table, this is what happens. Group 1 and group 2 are collectively known as S block. Your transition metals are known as D block. They always end in D. And your nonmetals are P block. And these two groups here, which we usually don't go there, are F block. So redundancy, S block, D block, P block, F block. So if you are given an element that is located here, make sure you end in D. And if you are here, you are in P. And if you are here, you should have F going for you.